At 20,000 feet over Nazi-occupied Europe, a B-17 flying fortress was already in trouble. The sky around the bomber was filled with black bursts of German flak. Fighter aircraft were moving through the formation, searching for weaknesses. Inside the B-17, 10 American airmen were strapped into their positions, surrounded by aluminum, cables, ammunition, oxygen lines, and 4 massive radial engines. Then came the explosion. One engine was hit. The propeller slowed. Smoke began pouring across the wing. The bomber was still flying. But the crew knew this was only the beginning. A second engine began losing power. The B-17 dropped lower in the formation, struggling to maintain speed. The other aircraft continued toward the target while the damaged fortress fought simply to remain airborne. Then another hit. The third engine was gone. Now the situation seemed almost impossible. 4 engines had become one. And the aircraft weighed roughly 30,000 pounds or more, depending on its load and fuel. It was never supposed to cruise across Europe on a single engine. Yet the crew still had one thing on their side. The B-17 had been designed with failure in mind. That sounds strange today. Aircraft are designed to be reliable. But during World War II, reliability alone wasn't enough. Combat aircraft had to survive bullets, flak, fire, mechanical failures, and sometimes catastrophic structural damage. The B-17 was built around 4 engines because 4 engines gave the aircraft redundancy. If one failed, the bomber could continue. If 2 failed, it could sometimes limp home. But 3? That was another story. With only 1 engine producing useful power, everything became a battle. The pilot had to manage airspeed carefully. Too slow and the bomber could lose lift. Too fast and the damaged aircraft could waste precious power. Every turn became harder. Every change in altitude mattered. And there was another problem. The engines weren't just pushing the aircraft forward. They were mounted across the wings, and asymmetric thrust from a single operating engine could make the bomber difficult to control. The pilot and co-pilot had to fight the aircraft every second. Behind them, the crew was dealing with an entirely different nightmare. Fuel could be leaking. Electrical systems could be damaged. Hydraulic lines could be failing. Ammunition could be scattered across the compartments. And somewhere inside the aircraft, an airman might be wounded and waiting for help. Yet the B-17 continued forward. That is what made the Flying Fortress so famous. Not because it was invincible. It wasn't. Hundreds of B-17s were destroyed during the war. But the aircraft gave its crews something incredibly valuable. A chance. A chance to absorb damage. A chance to keep flying. And, if everything went right, a chance to come home. So what exactly made the B-17 so difficult to kill? Was it the engines? The structure? The controls? Or was its legendary toughness actually the result of dozens of small design decisions working together? To understand why a B-17 could sometimes keep flying after losing 3 engines, we have to look inside the machine itself. Because the real story of the Flying Fortress wasn't simply about surviving damage. It was about what happened after the damage occurred. The first secret was obvious when you looked at the B-17 from the outside. 4 engines. That meant 4 independent sources of power. The B-17 used Wright WWII Cyclone radial engines, air-cooled power plants that had already become proven technology before the heavy bomber entered combat. Each engine could produce well over 1,000 horsepower, depending on the version. Together, 4 engines gave the B-17 the power it needed to carry a huge bomb load, defensive guns, fuel, armor, ammunition, and its crew across enormous distances. But the 4-engine arrangement had another purpose. Redundancy. If one engine failed, the remaining engines could compensate. That didn't mean the bomber would fly normally. It meant it could potentially remain in the air. And that distinction was critical. A B-17 with 1 engine out would lose performance. It might struggle to climb. Its speed would fall. Fuel consumption could change dramatically. But it still had 3 engines. If another engine failed, the situation became far more serious. Now the bomber had only 2 sources of thrust. At this point, the crew might have to abandon the mission and head toward home or the nearest friendly airfield. But the aircraft could still potentially remain airborne. Then came the nightmare scenario. 3 engines gone. The B-17 was now relying on a single power plant. The remaining engine had to overcome enormous aerodynamic drag while keeping the aircraft moving fast enough to generate lift. This is where the pilot's skill became just as important as the aircraft's design. The pilot couldn't simply point the nose toward England and hope for the best. The damaged bomber had to be flown carefully. A turn could become dangerous. A climb could be impossible. The pilot had to maintain enough airspeed while preventing the aircraft from yawing uncontrollably toward the dead engines. Inside the cockpit, every movement mattered. But there was another reason the B-17 had a reputation for toughness. Its structure was designed to withstand the punishment of combat. The aircraft had a strong semi-monocoque fuselage, reinforced internal frames, and a wing structure capable of carrying enormous loads. That didn't make it bulletproof. Instead, it meant that damage didn't always result in immediate structural collapse. A projectile could rip through the fuselage without destroying the aircraft. A section of the wing could be damaged while the remaining structure continued carrying the load. A control surface could be partially destroyed while the pilot retained enough authority to keep flying. And this created some of the most unbelievable images of the war. B-17s returned with enormous holes in their fuselages. Some had shattered engines. Some had damaged tails. Some were missing sections of skin. Others were covered in bullet holes. Yet the aircraft had somehow remained controllable. But there is an important misconception here. The B-17 wasn't magically capable of surviving anything. Its reputation came from a combination of engineering, redundancy, maintenance, pilot skill, and sometimes pure luck. A damaged aircraft could still be lost. A fire could spread. A structural failure could become catastrophic. A wounded pilot might not be able to control the aircraft. And if the final engine failed, the fortress became a glider. That's why every damaged B-17 returning from a mission was a story in itself. The crew didn't know whether they would make it. They only knew that the aircraft was still responding. So they kept flying. Imagine the final minutes. The bomber is alone. 3 propellers are frozen. Smoke trails behind the wings. The remaining engine is screaming under enormous strain. The crew has almost no margin for error. Below them is the English countryside. Ahead is the airfield. The runway seems impossibly small. The pilot lowers the aircraft. The wheels touch the ground. And for the first time in hours, nobody is shooting at them. The engines wind down. The crew climbs out. Then they look back at the aircraft that brought them home. And that's when the name Flying Fortress suddenly makes sense. The B-17 Flying Fortress earned its reputation in one of the most brutal environments imaginable. Thousands of feet above Europe, surrounded by enemy fighters and anti-aircraft fire, crews were asked to do something almost absurd. Fly directly into danger. And then fly back out. The B-17 didn't guarantee that they would survive. No aircraft could. But it gave them something incredibly important. Margin. For engines meant that losing one didn't necessarily mean losing the aircraft. A strong airframe meant that some damage could be absorbed without immediate structural collapse. Redundant systems meant that certain failures didn't instantly become fatal. And the aircraft's relatively stable handling characteristics gave experienced pilots a chance to keep control when the machine was badly damaged. But none of this tells the whole story. Because behind every battered B-17 was a crew. 10 men who had to keep working while the aircraft shook around them. The pilot had to fly. The navigator had to calculate. The bombardier had to do his job. The radio operator had to communicate. The gunners had to defend the bomber. Engineers and crewmen had to deal with fires, damaged systems, fuel leaks, and mechanical failures. Everyone had a role. And when something went wrong, they couldn't simply stop. They had to keep moving. That's why photographs of damaged B-17s became so powerful. A giant hole in the fuselage wasn't just a piece of damaged metal. It represented the moment when a crew should have died, but didn't. A destroyed engine wasn't just a mechanical failure. It meant the aircraft was now flying with less power, less speed, and less margin for error. And when 3 engines were gone, the situation became almost unbelievable. 1 engine. 1 chance. 1 long flight home. Yet sometimes that was enough. The B-17's greatest strength wasn't that it could ignore damage. It was that it could survive damage long enough for its crew to do something about it. That distinction matters. Because the Flying Fortress wasn't indestructible. It was vulnerable. It could burn. It could break apart. It could disappear from the sky in seconds. But when everything went wrong, its design often gave the men inside a few more seconds. And in aerial combat, a few seconds could mean everything. For the crews who climbed aboard those bombers, the B-17 wasn't just another aircraft. It was their transportation, their weapons platform, their shelter, and sometimes their only path back home. So the next time you see a photograph of a B-17 returning from a mission with engines missing, holes across the fuselage, and smoke trailing behind it, remember what you're really looking at. You're not looking at an invincible machine. You're looking at an aircraft that was pushed far beyond what it was supposed to endure. and a crew that refused to give up while it was still capable of flying. For engines took them into the war. Sometimes one was enough to bring them home.